All right. Good morning, and welcome to the fun part of class. At least in my mind, that's what I call it. We're going to enter into uh, the last 3 weeks of lecture, and then we have finals after that. During these 3 weeks, I'll be going through one project a week that are a little bit more fun. This week's project is an image processing app. Next week, we will get into graphical user interfaces, and the final week will be devoted to developing a game. So that's kind of the roadmap for the rest of the class. We're kind of done learning new technical or programming constructs, and from here on out, we'll kind of be dealing with the specifics needed to understand and deploy those three apps. So that's kind of where we're headed from here on out. Hopefully you're keeping up with the assignments. If you haven't, you probably want to work on getting caught up before jumping into these, even though they are a little bit more fun. But that's up to you how you want to do things. Some of them make more sense if you have completed the object-oriented part of the class. So let's jump in here. So the first thing, before we can talk about how to edit images in Python, we need to understand how images work a little bit. Now, I'm not going to give you super deep technical information, but you do kind of need to understand how a computer looks at an image, because contrary to what it might seem with this age of AI and being able to develop images from zero with AI prompts, images are still just a bunch of dots on a computer screen. Okay, and that's how the computer sees it. At a base level, the computer just says, here's a dot that's a different color, and it does that times a million, and it organizes those dots in a certain way, and what we see is a picture. Sort of like how we look at the words Bakersfield College in text in Python, and we see words that represent something to us. The computer just sees a bunch of characters, a string, right? So images like this strawberry here, if we zoom way in on the image, and this used to be a lot more apparent, right? When I was growing up, here's a when Bill was growing up story for you. When I was young and I was programming computers on my Commodore 64 and programming BASIC, that computer couldn't show too many pixels on the screen. It was a very low resolution. And so if I wanted to create a game on my computer, where I had two guys doing karate fighting or something like that, which was kind of like one of my many obsessions when I was creating games when I was younger, you'd have to use your imagination a little bit to see the guys, because mostly it just looked like a bunch of pixels on the screen, a bunch of square dots that were kind of like doing stuff. And if you kind of squint and tilt your head a little bit and use your imagination, you can see it. But now we've got ultra realistic, very, very high resolution screens on all of our devices. And so it's easier and takes a lot less imagination to see a picture on our screen and decide what it is. And yet, if we zoom in on any image on any computer on any screen, what you will see if you zoom in enough is this: pixels. Okay, pixels are the dots, the square dots that make up every single image on every single computer. And every single image on every single computer, on every single screen, has a limited number of possible colors that it can be. Now, our human eye can see massive numbers of colors. And even the most advanced screens and technology can only show a small fraction of those. It's the number 256 times 256 times 256. Now, where do we get that from? Where does it come from? It's because every pixel is made up of a combination of three colors, red, green, and blue. If you're older, you may remember, or if you have a grandparent or a great-grandparent that had a really old TV in their house, you might remember seeing a television set that boasted that it was RGB color. Well, RGB color simply means that all the colors on the screen are made up of red, green, and blue light. And in fact, older TVs used to have red, green, and blue projection units in the back of them that would project varying levels of red, green, and blue onto the screen. Why? Because at full strength, the perfect red, the perfect green, and the perfect blue, if you shine them together in one place, they make white. That actually creates a white light. And so what we can do is, by using varying combinations of those three colors, we can achieve millions of color variations between black and white. So every pixel, if I measure it, will have three different numbers: red, green, and blue. Those numbers will vary between 0 and 255, which is where we get 256 to the third power for the total number of colors that are possible. Every pixel on your screen, every pixel in this image. Now you can see there's a lot of variation in this color, even on a projection screen. You can see that even in the red, the strawberry is red, we would say that, but that red strawberry has a lot of different colors in it, right? The seeds are a little bit more black, the reflections are a little bit more white, there's some green in here in some of the seeds. There's a lot of stuff going on. And so when we are modifying an image, when you take an image and you pull it into Snapchat or Instagram or one of the multitude of other filtering apps that live out there online, all you're doing is you're taking that image and you're changing the color of the pixels in that image. That's it. That's the whole story. So if you change them in a certain way, then it produces certain kinds of effects. It can make the picture look like an old-timey kind of picture, or it can make it look brighter or darker, or the color's more vivid. All of that is possible just using different numbers in each of the pixels.